Hello all, let's start part 2 of section 1.4. As I promised that I'll do this video in 2 parts. In part 2 of this lecture, I'm covering how to multiply complex numbers, correct? We will start with multiplying complex numbers. To remind ourselves one more time, the first day I discussed with you that the square root of -1, we name it I. And if we square both sides, we end up with I square equals -1. I changed the color in red to explain to you when you are multiplying complex numbers, remember this rule that I square, the value of I square is always -1. When you multiply two complex numbers, or 3 or 4, when you are multiplying complex numbers, everywhere that you end up with I square, immediately substitute or change I square with its value, which is -1, or substitute -1 as a value of I square in the process. What the rule says, which rule we are using to multiply complex numbers, we are using still the FOIL method, correct? That everyone knows what does it mean FOILs. F represent first, O represent outside, I represent inside, and L represent last. For example, I'm not here explaining first the complex numbers. If I have A plus B times A, let's say plus B, FOIL says multiply the first term to both. It means A times A gives you A square, and A times B gives you B square. Then multiply the second term to both, which gives you AB plus B squared. What I did here, why I'm writing B squared? A times A squared, and A times B gives you AB. Correct? And after that, you are adding like terms. We follow the same rule when we multiply complex numbers. It's that easy. The only thing that we do when we combine, if we see somewhere we have I squared, we replace the value of I squared with -1. Let's do a few examples. Let us start from very, very easy ones. I will start with easy ones. Example number 1. If they ask me to multiply 4i with 3i, what I do, I will multiply the numbers. 3 times 4 gives me 12, and I times I gives me I squared. Here you go. I end up with I squared, and I'll just replace its value. Then it will be 12 times. What is the value of I squared? I squared is -1. And what is 12 times -1? Of course, my answer is -12. Example number 2. I'll copy this one from your book. 4i times 3 minus 5i. I'll use the distribution property. 4i times 3 gives me 12i. Now distribute 4 to the second term. Positive times negative gives me negative. 4i times 5i gives me 20i squared. The only part that I have to simplify is here because I have I squared. I'll replace it with -1. Then 12i minus 20 times, instead of I squared, I will write -1, which I'll end up with 12i. Negative times negative gives me positive plus 20. Remember the first day I told you that we are trying to write our answer always in the form of a plus or minus bi. Real part, then imaginary part. Then I want to rewrite my answer in a really correct and beautiful form, which is this form. Instead of writing 12i plus 20, I will write 20 plus 12i to be in this form. If your answer is 12i plus 20, it doesn't mean that you did wrong. It's not wrong, but everyone wants to write a complex number in the given form, required form, which is a plus or minus bi. Correct? Let me do another example for you. Example 3. I'll do a lot of them. I'm going a little bit slow this week. You see, we are in the second week. We just start the second week, but your lectures are really slow. Maybe chapter 1, we are going slow. I want you to get prepared. In chapter 2, we are going a little bit faster, not too much fast. And as soon as I see that you are ready, you're ready and ready and ready, then we go faster and faster and faster, correct? Let's multiply this time this problem. 7 minus 3i times -2 minus 5i. In this problem, because I'm multiplying two binomials, two complex numbers, I'll use the FOIL method. First, I will distribute 7 to the second parentheses, and I'll write the result. Positive 7 times -2 gives you -14. Positive 7 times -5 gives you 35 and I. Now, I'll distribute the second term to the second parentheses. Negative times negative gives me positive. 3i times 2 gives me 6i. And negative times negative again gives me positive. 3i times 5i gives me 15i squared. And next step, I'll replace the value of I squared with -1, and also I will combine like terms. You see, I have -35i and I have +6i, which I can combine them, like then -14, -35 +6 gives you -29i plus 15, replace the value of I squared with -1. Now simplify, which is equal -14 minus 29i. Positive times negative gives you -15. Now, again, you see you have like terms. Combine them. -14, -15 gives you -29 minus -29. I final answer. correct? This is the way that you multiply two complex numbers. Now, a special form of binomials. Remember in intermediate algebra, when you are multiplying two binomials like this, a plus b times a minus b, binomials are totally the same. The only difference is this sign. Here you have plus sign, here you have minus sign, correct? When you multiply these two, your answer was a squared minus b squared, difference of the squares. At the same time, I'm hoping and I'm sure that your professor explained to you that the left side, which is a plus b times a minus b, we call them conjugates. Correct? A plus b and a minus b, they are called conjugates to each other. A plus b is the conjugate of a minus b, and a minus b is the conjugate of a plus b. Remembering this rule, now if you have two complex number that they are the same, the only difference will be the sign between them. For example, if you have a plus bi and you multiply it with a minus bi, basically it's the same form. Let me zoom in a little bit. It's the same form as a simple one that I explained for you. We call these two complex number conjugate to each other. And what is the answer? What is the answer when you are multiplying two complex numbers that they are conjugate to each other? Your answer is a squared plus b squared, not like this, not minus. The only difference is a squared plus b squared. That is the rule that you should remember. Maybe you ask me why. If you want to see it, why? Let's distribute and see is this formula or if this rule that I gives you is correct or not. I'll do a little bit of kind of proof here for you, but you are not required to learn the proof. Just remember this, correct? How to multiply two conjugate complex numbers. But to show it for you, let me show here why. Look, a plus bi times a minus bi. Let's use our FOIL method. Distribute the first term to both, correct? It means it gives you a squared minus a b I. Now distribute the second term to both, which gives you positive abi minus bi b squared I squared, correct? Clearly you can see that negative abi and positive abi cancels out. And you end up with a squared minus b squared. Instead of I squared, I can replace it with -1, correct? And if I multiply, it gives me a squared plus b squared, which is the formula. Then my formula is correct? Every time we are using a lot the conjugate method, especially soon I will explain to you the division. When you divide complex numbers, you have to always multiply with conjugate, correct? You don't need to go this far, this too long. Immediately write the answer. Square the first term and square the second term. Always the sign in between should be positive. Let me do a numeric example for you. 2 plus 5i times 2 minus 5i. I don't want to go long way to show it for you. But if you don't remember the formula, somehow it's a test day and you don't remember the formula, always you can distribute and solve. But the easy way, what I do, I'll square this number. What is the square of 2? The square of 2 is 4. I always keep the sign in between positive. And I'll just square the second number. What is 5 squared? 25. And if you add these two, it gives you 29. Correct? This is, we call these two parentheses the conjugates. This was all about multiplying complex numbers. Now, let's start dividing complex numbers. How we can divide complex numbers. Again, if I want to talk about intermediate algebra a little bit, then jump back to complex numbers. When you are in intermediate algebra, if you have 2 over, for example, radical 3 minus 4, on that time, your professor mentioned for you that to divide this, to simplify this fraction, you have to multiply the denominator and numerator with the conjugate of denominator. What is the conjugate of denominator? The conjugate of denominator is radical 3 plus 4. You will multiply it here and you will multiply it also in the top. Radical 3 plus 4, correct? I don't want to simplify this problem because this is not our topic of discussion. Here we are talking about complex numbers, but I'm just telling you, when you had radicals, a binomial in the denominator, and your binomial involves radical in it, you have to multiply with the conjugate to can simplify or to can perform the division, correct? We use the same method to divide complex numbers. For example, let me explain it for you in an example. Example number 1, I'll copy it from your book. If they give me 3i over 4 plus I, and they ask me to simplify or divide, what should I do? My first step is to look at my denominator and multiply the numerator and denominator with the conjugate of the denominator. The conjugate of denominator is 4 minus I. And I will multiply the same number in the top, 4 minus I. Correct? That's your step 1. Step 2, in the top, if you have one term multiplied with parentheses, you know how to proceed. Of course, you will distribute, right? You will distribute this term to the parentheses. It means you will rewrite as a 3i times 4 gives you 12i. Positive times negative gives you negative. 3i times I gives you 3i squared. Again, if you don't remember your formula, the conjugate formula, here you have to file, your problem will be much longer. But if you remember it the easy way that I explained for you, square the first term. What is the square of 4? 16. Keep the sign in between positive. And square the second term. What is the square of I? The square of I will be I squared. Correct? Now, everywhere that you see I squared when you multiply or divide, I told you to replace it with what? With -1. Then I'll end up with 12i in the numerator minus 3 times -1 over 16 I plus, what is I squared -1? Simplify, which gives you 12i, negative times negative, positive 3, over 16 minus 1 gives you 15. Now, that is the answer. Even you can simplify, you can see you can factor the top, or you can write it as a two separate fraction. But again, remember, you should write your answer in the form of a plus or minus bi. To write down your answer in this format, you know, if you have a fraction with a single term in the denominator and multiple terms in the numerator, you can write them as a partial fractions, correct? You can write this one as a 12i over 15 plus 3 over 15 as a two fractions. If you can simplify, simplify. 12 and 15, both of them can be divided by 12. Let's simplify it by 12. 3 goes 4 times to 12, and 3 goes to 15 5 times. Here, 1 and 5. Then my final answer will be 4 over 5i plus 1/5. But still, you see, it's not in the given format. It's a correct answer, but I want to write my answer in the form of a plus bi. What I do, I will write first 1/5, then plus 4 over 5, and I'll put I here. A plus bi, and I'm in the correct format. Correct? Let's do another example. Example 2. 7 plus 4i over 2 minus 5i. The only thing that you have to focus on it is when you want to divide, you have to multiply by the conjugate of denominator. Then I will multiply my fraction with this. What is the conjugate of denominator? The conjugate of denominator is 2 plus 5i. And here denominator 2 plus 5i. Correct? In the numerator, I have no choice. What I do, I'll use the FOIL method to simplify. 7 times 2 gives me 14. 7 times 5i gives me 35i. Plus 4i times 2 gives me 8i. And 4i times 5i gives me 20i squared. Denominator, I'm using my formula. The square of the first, 4, plus the square of the second, 25. Also, let's do another step here. Replace our I squared with -1 to make it kind of faster, correct? Positive times negative gives you -20. -20 and 14 gives you -6. 35i and 8i gives you 43i I over 29, correct? Now you can write as a two separate fractions in the form of negative 6 over 29 plus 43 over 29 and keep your I at the end and you are done. You are in the form of A plus BI. This is what we call the four operation of complex numbers, correct? Now, another topic of discussion that we already discussed before is dealing with the roots of negative numbers, correct? Roots of negative numbers. Remember, I explained to you the first day when I start with imaginary numbers, or I can call it complex numbers, correct? I explained to you that if I have a negative number under the square root, correct? For example, if I have the square root of negative b, b can be any number. To take the square root, I'll take the square root of b, whatever b is, the square root, and because of this negative, I'll represent my negative as what? As I. Usually we should write this way, B and I at the end, but we are trying to avoid when you are writing radicals to put the I at the end because some of us, we write radicals like this. We continue with our line like that, and by mistake, if you put your I under the radical, your answer is wrong. That's why I prefer, or even in your book, everyone prefers, when you are writing I, after a radical, it's better, or after a root, it's better to put it before, right? To avoid this mistake. Now, when we are performing operations with the square roots, with the negative numbers, we have to focus on few things. For example, they are not like very simple that we think. If someone gives me to multiply square root of negative 5, very easy with the square root of negative 4. Some of us, we think that, oh, let me use the rules of radicals because the indexes are the same. I can rewrite this one as a square root of negative 25 times negative 4 under one radical. Don't do this. This is wrong. When you are dealing, when you are multiplying square roots, that your radicand is a negative number, how to proceed? First, find it as an imaginary number. What does it mean? What I mean? Let's rewrite. Square root of 25 times the square root of negative 4. Now you learn how to take the square root of a negative number. The square root of negative 25 is actually 5i, right? We discussed. Times the square root of negative 4 is 2i. Now multiply these two. 5 times 2 gives you 10, and I times I gives you I squared, and you know I squared is negative 1, then negative 1 times 10 gives you negative 10. That is the correct answer. If I go this way, let me finish this. If I go this way, this one will be the square root of 4 times 25, which gives you a positive 100. And the square root of 100 is positive 10. You see, your actual answer should be negative 10, but here you end up with positive 10. That's why I'm saying it's incorrect. It's wrong. Whenever you have a square root, that you have the square root of a negative number, first simplify it or first rewrite as an imaginary number, then multiply. Correct? This was all about section 1.4. I'll stop the lecture here and see you soon in section 1.5. Our section 1.5 is really interesting. We are discussing quadratic equations, correct? See you all in section 1.5.